Hello everyone, welcome to the stream. Today is another day of daily programming. Today we got another problem to work with in LeetCode called reverseInteger. Given a 32-bit signed integer, reverse digits of an integer. For those who aren't sure what a 32-bit signed integer is, data all has to be stored in a certain amount of bits, and this one's given 32 bits. 32 bits is composed of 32 ones and zeros, which is equal to 4 bytes. Kinda like this. Also, a signed integer uses one of its bits as a sign, which means one of these bits is not available for use as part of the actual number, and what this effectively does is cut the number in half in both ways. So, if you were to look up 32-bit signed integer in Google, it will tell you what the number would be at the max. Now, this is only for a signed integer. If you want to do unsigned, it should be double this. So, but most of the time people only talk about signed numbers. You only see unsigned stuff in the likes of like a C programming language. Anyways, with that fun little fact out of the way, let's get to work. So, given a number, we have to reverse the digits. So the easiest way to work with numbers is by turning it into a string. It's one of the easiest ways to manipulate numbers because we as humans understand strings better than we do actual number manipulation. However, if you want to do this using number manipulation, you would have to do some clever mathematics. We can go through both solutions today. I feel like that would be pretty fun. You might notice that one of the examples has a negative number, so we have to take into account negatives. Assume we're dealing with an environment which could only store integers within the 32-bit signed integer range. Assume your function returns 0 when the reversed integer overflows. Interesting. In any case, when reversing the number, you might sometimes end up with a larger number than you started with, or a smaller number in the case of negatives. So that's what they mean. If the number you return ends up being larger, like overflowing, then you can return a 0. The way to deal with underflows or overflows is usually through exceptions. Like usually an exception gets thrown, but you can catch that and then usually return something else. So we'll get to that when we get to that. First, let's go through the string solution, as that's pretty easy to deal with. In Java, integer.parseInt, that function will turn any integer into a string. So that's where we're going to use to turn into a number. To reverse all the digits, you basically start at the first place value and work your way up to the last place value, appending it in that order. So, if we start at the last place value, the rightmost value, we're going to be starting at, we're basically initializing a for loop here. We'll be starting at number.length minus 1. We have to do minus 1 because the array elements, or the characters, this is character 0, character 1, and character 2. So if the string length is 3, character 2 is the rightmost one. So you have to always subtract 1 from the length. And while I is greater than or equal to 0 until we reach the -1 slot, we won't stop. Subtract 1 from I each time. And then string answer will start out as a blank string and we'll just append to it. So answer plus equals, and then we provide a character, number.character at I. Then we return the answer, but converted back to a number. So, I think I did this wrong. This is supposed to be integer.toString. Parse int interprets a string into an integer. So that's what we'll do. Answer, like so. So we'll return the parsed version of that. So let's go ahead and hit run code. See, that gives a comprehensible result. As you can see, it does. So we'll just hit submit here. So you can see number format exception. So I purposely ignored the negatives right now so we can see that indeed the negative is included. So we're gonna have to add a condition. If the character is a negative at the start of the string, we need to consider that and multiply the number by -1 at the end. So basically the order will go store the number into a string, check if it's negative. If number.character at 0 is equal to a minus sign, then we are gonna store a value called is negative. And it'll be a boolean set to false by default, but then turned into true when we find a minus sign. Additionally, we don't want to hold on to that minus sign. So what we will do is we will update number and say number, inside of here, we'll say number is now going to be equal to, I believe we can use substring here. Substring has a begin index, and you can specify an optional end index. But if you include a begin index, basically we could say number 1 or number.substring 1, and this will mean starting at the first index onward, like from the number 1 instead of the minus sign, keep everything else. So we're just going to update number to remove the minus sign. Now if we were to hit submit, I believe we would get a more comprehensible result here. We just have to actually multiply by -1 now. You can see it expected -321. We only provided 321. So now we're going to add a multiply here, and we're going to do a ternary operator where we say if is negative, then multiply by a -1. Otherwise, multiply it by 1, effectively not multiplying it by anything at all. So let's see what else we got. We have for input string 964632431. There was a number format exception. So when you're reading a stack trace, a lot of times extra things will be called, right? Because of the functions you're using. You need to go down to where your program is. So it says at line 16 of solution.reverse. You can see it actually exclamation points it here though. There was a number format exception for that input string. Now, why? This was the input, that was the output. Let's look at what the number actually is though. The number is 9,646,324,351. Now remember, what was the integer range? 32-bit signed integer. It's 2 billion. So when this number is too big, we can't accept that. So you can see we get a number format exception. So, because we were given a number format exception, that is what we can actually catch before this happens. So this is where a try catch comes into place. Basically, you can wrap an exception inside of a try catch loop, or not loop, but method. And this allows you to catch the exceptions and then do something else. The problem wanted us to return a 0 if we had number overflow. At least that's what it told us. So that's exactly what we're gonna do. So you can see we have a success. And that's all great. But this was a string solution. I want to show you how to do this mathematically as well. as it's also an interesting problem. So this is one valid solution, but let's do another solution. So I'm gonna turn this into a reverse string, and we'll make another function called reverse inside of this class. So this should run without errors. It's not gonna give the right results, but at least it should run. Okay. So we'll be making a mathematical calculation for this as well. So the algorithm is the same. Ideally, we wanna grab the number, read it starting from the lowest place value to the highest place value. But now we want to do it with numbers. Well, how do we get it with numbers, you might be wondering? Well, there are a couple of ways. To get the place value of any number at its current position, we can use the modulus operator. And the modulus operator basically returns the remainder of a division operation. So if we have a number like 9642, what happens if we do 9642 modulus 10? Well, we're going to end up with the number 2. You might notice that the number 2 is the last place value in that number. So that's kind of interesting, right? What happens when we cut off the 2 and do it again? We end up with the number 4. So as you can see, the modulus operator is the way to get, doing modulus 10 at least, because we are using a base 10 counting system, is a way to extract the first place value in a number. Which is great, because when we're doing reverse integer, that's what we want. We want to start from the back and work our way to the front. So that's going to be our operation we use for that system. Now what about to create our number, if we want to do it solely with mathematics? Well, we would, the first time, if we still use 9642 as an example again, our answer would first store the number 2, right? And then on the second one, it would store the number 4. But it needs to store the 4 in the 1's place value. So what happens to this? Well, we need to multiply by 10 with the number in that slot to move it over. So, if you take your total, which in this case will be 24, and you multiply by 10, you get 240. Then you add what the modulus 10 of 960, in this case 96 is, which is 6, and you end up with 246. So, basically, multiply your current answer by 10, then add whatever modulus 10 of the remainder is to get your final result. And that's how you can do this with the mathematics. So now let's try to incorporate that. So x will be our number. We'll just modify it in place. That's fine. And then we'll have to store our answer somewhere inside of a number, and it'll start at 0. We haven't talked about negatives yet. So we need to first detect if it's negative, and if it is, we need to remove the negative, because otherwise these operations we're doing are going to get messed up. So again, we can use something similar. Is negative? We'd start, let's use a ternary operator for this. It's always good to practice what we learn. So if x is less than 0, we know it's going to be a negative number, so return true, otherwise return false, right? You can just make is negative equal to is x less than 0. That's essentially the same thing. So now that we have that, let's start creating our answer here. So how do we know we're done? Well, when when x is 0. So we're going to use a while loop, because we don't know how many times we have to do this. We can't really count the number of digits unless we go through and do this ourselves. And since we're already doing it anyways, might as well say while x is not equal to 0, we're going to be modifying x until it becomes 0. So first, get the last digit. So last digit will be equal to, we said we do the modulus 10 operator. Great. Then we have to remove that amount from the current x. So how do we do that? We have to actually divide by 10. So because of how integers are rounded when you do division, if we do 9642 divide by 10, right? We end up with 964, and the 0.2, the decimal place, just straight up disappears. So that's the operation we need there. So x will be equal to x divided by 10. Or if you want the shorthand, divided equals 10. Same thing. So we're storing our last digit. We have removed one place value from x. Now let's add the place value to our answer. Remember, the operation is multiply our current answer by 10, so answer times 10, then add whatever the digit is to get our new answer. And this will just repeat and repeat and repeat, cutting down the x while adding to our answer. Finally, if is negative, we need to multiply by -1 on our answer. And finally, we can return our answer. So we're making sure this works. We hit submit again. And it says there was a wrong answer. Expected -321 and got 321. So let's have a quick look at our logic here. If is negative, answer is multiplied by -1. Well, we know we reversed the number correctly, so why didn't it multiply it by -1? Oh, you know what? I know why. We didn't actually take out the negative before we started doing all of our operations. I wonder then, if we just leave it in, do we even need to check if it's negative, if all of our number operations work while it's negative? It doesn't look like it. Ah. You can see a new problem kind of arises when we try and reverse a number like this. What happened here, you might be wondering? Well, it overflowed, but when integers overflow, they don't throw an exception. What they do instead is they just wrap around. So for example, if we reach the number 2,147,483,647 and we add 1 to it, we're not going to get an error, we're just going to get the next number. So just to demonstrate, we're going to make an int called maxInt equal to integer.maxValue. That is an actual constant. And we're going to return maxInt plus 1. So if I run this code, what we should end up seeing is a negative version of the 2,147,483,648 because it's 1 backwards. So that's kind of interesting, right? If you add 1 to the max value, just to prove that it is the max value, I will run the code without it. You'll see you return 2,147,483,647, the max value. So when you add 1, it just wraps around because that's how it works in binary. It's like, it doesn't know that that's the end. It's just going to loop around like that. So we're going to have to come up with a way to check for that. There are a couple ways you can do it. You can check it with what are called long values, because long values store way more bits of precision. If you look up a long in Java, the long, let me see. It is 2 to the 63rd power. In other words, it's a 64-bit number instead of a 32-bit number. So one solution is every time we add to answer, we store the answer in a long, and if the answer gets too big, we say, oh, you're too big, return 0. That's a decent solution, right? The other solution is every time we complete answer, we're going to compare answer to its previous value and see, is answer less than it was before? Because if it is, that means it went backwards, because we're only adding numbers. So if we were to go backwards, then something is wrong. So I like the second one because it's a little more technical, and technical solutions are always more fun. Now you might notice I uncommented the is negative stuff, and that's important, because what happens if we're adding a negative number? It's going to go down instead of up. So whether or not it's negative determines whether or not we have to check, is the number decreasing or is it increasing? You need to have that dynamic. So we do need to know if the original number is negative, and based on that, we can now check what the answer would be. So we have to store the previous answer as well. Previous answer is 0. So every time answer is changed, check if. So if it's negative, we expect the number to go down, right? So we're gonna say if it's a negative and answer is greater than previous answer, that's a red flag for us, because why would the answer go up if we're a negative number? That doesn't make sense, right? Because as we add more digits to a negative number, it gets smaller. So that's a red flag. We're gonna return 0. That shouldn't be happening. Additionally, we're gonna check the opposite logic. Else, if it's not negative, so if it's positive, and the answer is smaller than the previous answer, then also something bad happens, so return 0. And then set answer to previous answer after we checked our answer. That way the next answer will be equal to the next value. So just make sure our old code still works the way it's supposed to. Oh yeah, I still have this max int stuff here. My bad. Let me remove that real quick. Oh. So we don't need this code right here because we're not actually reversing the answer as I originally thought we were going to. So that works. Alright, let's hit the submit button here. And we have a wrong answer here. Input was this, output was this, expected a 0. We did not give a 0, so something went wrong again. So if it's positive, because this number is positive, and the answer is less than the previous answer, which it should be in this case, you can see, right? Alright, let's maybe my solution doesn't quite work, because let's look at these numbers in detail here. When we're cutting up these numbers, this number is getting redone in reverse, right? So reconstructed like this. At this point, I don't think it's overflowing yet. It's only got 964 million. The moment we tack on that 1, boom, it becomes 9 billion. It doesn't work anymore. So it's more like that, and this number is smaller than the final result here. So this solution doesn't work in all cases. So that's a problem. That's a bug. We're gonna have to figure out a better way to handle that. Again, the long solution is pretty nice and it's pretty tempting. But is there a way to do it with just integers? One might wonder. Now, there are functions built into Java to also handle Java overflow. Integer overflow. So, I believe there is a... Well, there are topics that talk about this, and I think I've looked at it a few times. I remember there being a way to check. Interesting. Well, let's do our long solution for now, as that seems to be the simplest way we can come up with. So, here's what we'll do. Answer and previous answer will both be longs. And we'll check this way. And instead of doing this, we're gonna say if the number's negative, so we don't need previous answer anymore. We just need to check if answer is now greater than. So if it's negative and answer is less than integer.min value. So we can use min and max value, which determine the boundaries of an integer. And answer is greater than integer max value. If it's positive, return 0 as well. Finally, the program wants an integer, so we'll cast it back to an int if we get down here to safety. So we'll just verify that this indeed works and hit submit again. So you can see that it does indeed work. Wow, it says it's faster than 100% of Java Online submissions for reverse integer. So you can see this is a very, very efficient solution. It does use a bit of memory because it's storing it long. But this is the most efficient solution compared to something like this, which I think was like 6% or something. 7%. So yeah, very efficient solution in comparison to string manipulation. Why? Well, string manipulations have a lot of overhead. The string class itself has to do a lot of things in the back end, in the background, to handle all this. And the logic itself is a bit more complex, and we're using a loop. All these things add to runtime. And I mean, we're using a loop here, but you can see that this is a more efficient solution because we're handling numbers directly, and computers are very much optimized to handle numbers. Finally catching one of these live. Yes, welcome, welcome. Let me see. We're up to 30 minutes, so we're gonna actually head into another problem here. Next challenges. We're gonna head for this one. This is a medium challenge. So this is atoi. This is actually a very popular function in C. This is used to convert a string to an integer. We just did an integer in reverse by converting it to a string. So string to integer is almost the same concept. We kind of almost did that already. So this should be interesting to see. But there's a bit more to it. The function first discards as many whitespace characters as necessary until the first non-whitespace character is found, then start from this character takes an optional initial, plus or minus sign followed by as many numerical digits as possible and interprets them as a numerical value. The string can contain additional characters after those that form the integral number, which are ignored and have no effect on the function of this behavior if the first sequence of non-whitespace characters in string is not a valid integral number, or if no such sequence exists because either string is empty or it contains only whitespace characters, no conversion is performed. If no valid conversion could be performed, a 0 value is returned. Only the space character is considered a whitespace character, and assume we are dealing with an environment which can only store integers within the 2-bit signed integer range. So we already know what that is, as we talked about right now. If the numerical value is out of range, int max or int min is returned. So again, we'll be handling boundaries. You can see there are a lot more rules to this function. This is a much more structured function compared to the previous one we dealt with. So usually programming exercises intentionally have a lot of rules because they are meant to be challenging. So there's a lot to take in here. This can be any string that might contain a number in it, and we have to interpret it to the best of our ability. So let's handle it one at a time. Let's first try to handle whitespace characters. We're gonna be going through probably a loop and just interpreting each character into something important. So the first thing we're going to be look for a sign. A sign can be positive or negative. It also might be optional. We might not even find a sign. If we do find a sign though, that determines whether it's positive or negative number. We're also looking for numbers, and we ignore everything else. We don't have to worry about decimals because this isn't going to deal with any decimal numbers. This is just an integer. So it looks like we got the basics from that. We'll store a boolean called sign. True is positive number and false is a negative number. We'll just do it that way. Makes things easy. So we have to loop through this string. Starting through the entire thing. From start to finish. So if we haven't found a sign, then we'll look for a sign. How about that? I might turn this into an object and start it with null, as in we didn't find a sign, but if we do find a sign, we can mark it as such. So we have to read in each character. So character C equals string character at I. That gives us what character we're currently on, so we can compare. We don't have to type string.character at a million times. If C is equal to a plus, then we're going to set sign equal to true, because that means it's positive. If C is equal to a negative, we're going to set sign to false. Additionally, for both of these, we only can set it if sign is equal to null. So, once we set sign, we can't set it again, so we don't look for a plus or minus sign again. So that takes care of handling a sign. Now let's talk about handling numbers. Every time we get a number, we probably should store it inside of a number string, or we can just add it directly. I prefer adding it directly as a number, because that makes things easy for us. It's also faster, as we proved in the last example, by a ton to manipulate numbers directly. We'll handle a long, because if we get overflow, we can detect that very easily using a long versus using an integer. So, long number will be equal to 0 at the start. So, we'll use kind of a similar operation we used earlier, where we'll make the number be equal to the number multiplied by 10, and then we add whatever our new digit is going to be. So, in this case, we will interpret a... So we have to check if it's a number, first of all. There are a couple ways we could do that. The easiest way is to check the range between 0 and 9. Characters are stored in what's called a ASCII format. So if you look at ASCII codes of characters, you'll see we have some defaults here. I usually like this table. It's very clean and concise. So, how you read this is you're looking at the character column here to determine what character you're looking for. Let me zoom in a little. And so these represent what the actual character you're looking at are. In this case, we're looking at the characters 0 through 9, these numbers. Once you know what characters you want to search for, you need to go all the way to the left column here, the decimal column, which represents what the actual numerical value of the character is. That tells you their range. So you can see 0 is the smallest and 9 is the largest. So that's the range we have to search for. You don't have to actually know the decimal numbers, but you do have to know the ordering they're in so you can specify the range correctly. So in our example, we want to get any numbers from 0 through 9, but we're dealing with characters. So we're going to say if C is greater than or equal to the character 0, and C is less than or equal to the character 9, then we found a number, so we're going to add that number to our system. So you can treat these as individual numbers. They're just represented as characters here. The other way you could do it is by saying if C is greater than or equal to 48, and C is less than or equal to 57, if we were to substitute them directly. But it's a lot easier for humans to read these and say, oh, any number from 0 through 9. As another example, let's say we want to detect any like lowercase letters. So we would look for the lowercase letters here. In this case, it would be starting here. And we can see A is the starting point of that range, and Z is at the bottom here. So if we want to get any characters that are lowercase letters between A and Z, we would type in A and Z instead. Anyways, now that we've detected numbers specifically, we're going to convert that character into a number. I believe parseInt also accepts characters, but let's double check. So we'll go here to the parseInt method. This is not what I was looking for, actually. Stop. ParseInt. It looks like it accepts only a string. So, since it only accepts a string, we need to convert the character to a string. Sounds kind of silly, right? But, character.toString is going to be required here because the character is not a string. Even though it's just one letter in a string, it's not an actual string. So you can't actually... Oh wait, we don't want a string though. We want a number. Hold on. Right, so we still have to convert it to a number after the fact. Now, this is okay, but you notice we have to convert the character to a string, then convert the string to an integer. Sounds a little excessive, right? There's another way though. Remember, characters store numbers. Characters are numbers, essentially. So what happens if we instead take the number 9 and subtract it from the letter C? So, what this annotation says is, take the value 9, which is, I think, 58, if I recall correctly. We jump back a little bit. Oh wait, I still have this here. So yeah, if we just substitute the number 57 here, let's say the number was 2, right? We would get the number 50. So 57 minus 50 is 7. So 9 minus 7 is 2. It gives us an exact number we're looking for. So this is a way to immediately get an integer straight from a character, because characters are just numbers after all. You can do subtraction with them. So that's a very easy way to get that. Alright, so now we've handled all that, we just need to put everything together. Number is still a long. So, every time we do this operation, we're going to make sure we don't have overflow. Otherwise, we have to return int min or int max. So if num is greater than or equal to integer max value, we're going to return integer.max value. Because we already surpassed it. Else, we'll check for the min value as well. Alright, so we handled that condition. Now finally, we have to take care of the sign, because we haven't dealt with the sign yet. We've just been dealing with adding numbers to a number. So technically, it will never be negative, because we're never adding negative numbers. We're always adding positive numbers. So really, if we want to optimize this part doesn't have to exist. That's optional. So I will comment that out for the sake of this. So, if sign is not equal to null, we have a sign, so we're going to interpret it. If sign, well, it's positive, so we don't have to do anything. But if it's not sign, it's negative, so we have to multiply by -1. So take the number, multiply it by -1. Finally, return number. Let's do a test run. Incompatible types, possible lossy conversion from long to int. You're right. We need to cast it to an integer first. Alright, so your input is 42, output is 57, but we expected 42. That's interesting. So maybe we did the math wrong here. So, again, if the C character is something like 0, and we have the character 9 here, it should be 57 minus 48, which gives us... I see. We have this kind of backwards. We need to actually do C minus 0. Okay, I knew something was a little fishy when I explained that, because when I added it, I'm like, wait, it equals 2, which is 7, which is... yeah. So, take the character and subtract 0 from it to get the actual number we need. So, for example, again, we'll take 9 as the example. 57 minus 0 is 48. So 57 minus 48 is 9. There you go. That's what you're looking for. And let's say we had the number 5 here. So 53 minus 48 gives us 5. Alright. So that fixes that little issue. Just did some math wrong. So 42, 42, 42. Let's hit submit and see what happens. So, wrong answer. Words in 987, output was 987, but expected 0. Okay. So maybe I misinterpreted the thing here. It says, if the first sequence of non-white space characters in string is not a valid integral number, or if no such sequence exists, because either string is empty or it contains only white space characters, no conversion is performed. So if we don't get a sign, or we don't get a number right away, then we have to return 0, because we're not starting with a number, just like our example here, because it says words in 987, and we just interpret the 987. So for this problem, we're going to have to make sure that we're getting something valid at the beginning. Once we have something, I think we're set, because it just says the first sequence. After that, we're good. Alright, so we're gonna go Boolean. Actually, let's not do the Boolean. Let's do, we're gonna just store a Boolean that contains, first character found is false. So this is gonna store whether or not we have found a valid character, in general, right? So, first character found gets set to true if this, or this happens. So, if we find a non-numeric character, and we haven't found numbers yet, and it's not a plus or minus sign, so if C is less than 0, or it's greater than 9, and C is not equal to a plus sign, and C is not equal to a minus sign, and not first character found, we haven't found a first character yet, then we're going to return 0, because this is an invalid string. So it can't be, if we find a non-number that's not a plus or minus, and we haven't found a character already to represent a number, then we're gonna say this isn't a valid number. We can't accept that. Alright, so here we got a bunch of white space, then a -42 outputs 0 expected -42. Now here they say we're supposed to ignore white space, so we gotta include white space inside of here. And C is not equal to white space. White space is okay, that doesn't count for any code. So we gotta include that exception as well. Then here we got -91234 blah 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 blah. Output is this, but expected this, which is a negative. So the issue here is that this was negative, but we returned the max value. So we do have to return the min value if we get over the max value, but this is a positive number, so we need to look at the sign. So we need to say, if sign is not equal to null, check if sign is false. If not sign, then return the min value. Otherwise, we'll return the max value there. So that's another exception. The first two conditions are checked anyways via the first character found flag, so no need to repeat them. Can just directly say not first character found. The first two conditions are checked anyways. I'm not quite understanding. Oh look, they threw in a decimal point. So everything after a decimal point should be ignored, not converted. So if we find a decimal point, we need to ignore everything after it. That's an interesting one to deal with. So basically, if we find a decimal point, we're just done. That's it. Whatever number we have, we're just gonna get out of this loop, basically. We're gonna break out of the loop. So we'll put it below here, because if we find a decimal point first, then we kind of want to break out of this loop earlier. You can just check for white space and not first character found, because if c is greater than 0 or less than 9, first character found will be true always. Yeah, you're right. I agree. C is not equal to, or C is equal to a dot, then we're done. We're not gonna return, we're just gonna break out of the loop because we still have to do some final processing after that. Now we have this plus minus 2. So they're trying to trick us with these signs here. Because the minus sign is not a valid number. So after we find a sign, well, the next thing expected is a number. So if we find another sign value, we need to accept that as invalid because we haven't found a number yet. So we can't just simply plop in if it's not equal to plus or is not equal to minus. We also need to say if we haven't established a sign yet. So sign is equal to null, and in this case, if sign is null, and it's not one of those, or if sign is set, then it can be those. So we kind of need like an opposite logic here to counteract that. So here we can say or sign is set, because if sign is set, then we have to be careful though, because if sign is set, we don't want to just return 0. That wouldn't be good. C is not equal to space, and it's not a number. It's not the first character found. And that more or less makes sense to me. We set sign. So sign should be true at this point in time. At least I think it should be true. Oh, you know what? I need to say not equal to null. But I don't think that matters, because in this case it would have been positive anyways. I might have to do some debugging on this one, because this is a little more complicated logic compared to the previous ones. So because I know by this point sign has been set. So it should be false, or it should be true, true. Yeah, true, true. Oh, there's a third true. Why is there a third true? Oh, guess because we're interpreting the two. So true, true, true. First character was found, that's why. So this no longer applies after the first one. But first character found should, okay, so that's what it is. First character found should not be set on a sign. It should only be set on a number. So really, this doesn't represent the first character found, it represents a number has been found. So now we're gonna get some issues with this one, because we haven't set sign yet. We do ignore white space though, and this is all white space. Then we have negative. So That's kind of weird. Let's look at number. Because at this point, I think the number should have been built, at least. Huh. It's just called 4 times with the number 0. So is that 4 spaces? 1, 2, 3. That's 3 spaces and then the minus sign. The minus sign gets set. So sign is not equal to null anymore. Okay, yeah, so this is kind of like conflicting operations here. This check should probably happen... So I guess what should happen is if we set the sign, we can just continue to the next loop. We don't have to keep looking through this. We don't want to run the rest of the code. Kind of the same with the number. If we find a... Oh, wait, let's put it down here. If we find a number, we're not going to do this other stuff. We know now that's going to apply. Oh, goodness. Negative 0012A42, expected a minus 12. Okay, so the moment we get like a letter or something, we need to break off. We need to break off the number. The moment we find a letter. So, just like we did for this, if we find a non-number at this point, we just need to break. I guess, honestly, let's see. Because if it's a number, we'll continue. If it's a sign, we'll continue. If it's not the first character, we'll return. So anything else, we just need to break. Because everything else is invalid to us. Ah. Now what's wrong? Well, let's see. Oh wait, we were handling white spaces there, weren't we? Don't break on white spaces, that's like the exception. Let's see. We have a plus sign followed by 1, 2, 3. Output is 1, 2, 3, but expected is 0. Probably because the 0 and then the white space determines a break, but only if it's after the number, not before the number. So only white spaces in front of the number are considered to be ignored. So the moment we find a number, so first character found, which is now really representing a number, and not first character, or first character found, break. Expected a negative 21474 83647. Aha! So this catches my max value thing, because originally I interpret everything as a positive number. So we need to say, if it's a negative, we need to check with the min value and artificially make it negative to make sure that we're only giving a valid negative min value. If sign is not equal to null and not sign, and number is less than, number multiplied by -1 is less than or equal to integer min value. But this would still trigger is the problem, because it's an OR. So both of these, only one of these can be true. So we actually need to XOR this, which I believe is this. I rarely ever use XOR. I believe it's just a caret. Yeah. XOR means only one or the other can be true, not both. So either the number has to be greater than or equal to integer.max value, or the inverted version, with the sign being negative, has to be less than or equal to the min value. So if it's a negative number, and it reaches this value, then both of these would be true. So it's not going to return this min value thing, which it shouldn't. Actually, if it's a negative, it wouldn't return this because this number is one greater or one less than this. Because 648 is greater than or less than 647. So that logic doesn't really check out. How about instead, we'll just split it up into two statements based on whether the sign is positive or negative. That way we avoid that in the first place. So if the sign is positive, so either we don't have a sign, if sign is equal to null, or sign is not equal to null, and we have to check for nullness, otherwise we're gonna get a null pointer exception, which would be bad. We don't want that. Sign is not equal to null, and sign, and that. Okay. So that's more or less what we want. This is saying if we got a positive number, we're going to check with the positive value. Otherwise, we're going to check pretty much what we had down here. If it's a negative number, we're going to check with the negative instead. Guess I'm going to remove this now. Oh goodness, now what do we get? It looks like we were supposed to return integer.min value, but instead we end up with that weird thing. I thought we already made num along. It looks like we did. That's kind of interesting. This number doesn't even really represent like a reverse version of this either. It's just something really random. That's interesting. Might have to step through that because I did not expect that. I don't even know where it's getting these numbers from, so I guess we'll find out in a second here. Let's print out the original number, or the original string in this case. We'll print out the current number and the digit. Well, the number looks like it's constructed correctly, but on this next one, it decides to return something really random. I assume the reason it's returning here is because it entered one of these. Let's see which one it entered, if it entered one of these. In theory, if it were to go in here, I would expect it to go into this, but it doesn't output either, any of that. Interesting. Oh, this needs to be an or statement. That might explain it. Which would mean that never triggers. Okay. So I had an or instead of an or and instead of an or. So this expects 0 because the negative is separated by white spaces, of course. So if we find a sign, we need to also return 0 as well. So we're gonna have to continue to add to this, or first character found, or sign is not equal to null. Seems to be like a million exceptions to this thing, huh? 0 expected 0, but got -1. It ignored this 0 completely. That's kind of weird because it should have returned the number. So I mean, it would have went through here once and then would have went up here, huh? But we can only do this if we don't find and not first character found. Which means it would have went to here, and then we went down to here, and then that would have ended it. Or here, excuse me. There we go. So we finally made through it. That was a very difficult one. Partly because of all the exceptions, but I think that was kind of the challenge, really, because when building one of these, there's like, when you're building anything in programming, there's going to be a lot of like exceptions, right? There's going to be a lot of like random things thrown at you, especially for a string parsing function. A string can be literally anything, and so making a function to handle every possible case is you end up with like globs of mess like this. Refactoring it would be highly recommended at this point because I definitely changed like what this variable meant. It no longer means first character found, but it means a first number found. The sign variable was not implemented very well. Instead of using null, I should have probably used an actual enum that represented either positive or negative, something like that. Because we know a number starts out positive by default, and then it can be changed to a negative. So there's no reason to have this third state of nullness. It just added more complexity down here, because now we have to check for nullness plus check for the sign, if it does indeed exist. So it created this like third state that we didn't really like want to deal with, but we kind of had to because we were pushed into there. So that was kind of bad. Additionally, one of my viewers pointed out that I indeed had some conflicting logic, so that usually happens when you're just throwing in logic quickly. So that is conflicting logic because it's handled up here. So you're never going to have this because this will be true, and we're going to be setting this. So these two statements right here are never going to be true at the same time. So yeah, I mean, it works, but would anybody be able to modify this in the future if they need to add a condition? Probably not. It's very crazy looking, so refactoring would definitely have to be done. I'm kind of reaching my time limit, so I'm hesitant to actually do the refactoring now, but we might look at the refactoring another day. This was pretty fun though. It was challenging. One thing I did notice, I didn't want to say anything, but this problem has like almost 10,000 downvotes, and you can kind of imagine why, because this problem is very aggravating in that there are all these different exceptions and you have to cover them all. So I can imagine people getting very like frustrated over this problem and saying this can't be legitimate. Why would you handle this case this way and this case that way? So I can definitely see why people had a problem with this problem. It's more frustrating than it is fun to solve, in my opinion, once you get past, like, the initial hump of how do I develop the basic program. So yeah, that was pretty interesting, though. I think that's gonna be it for today's daily programming session. We've reached an hour. Like I said, didn't really have time to refactor this, but we got some stuff done. Got to show off a basic parsing or reverse integer solution. We actually did 2 of those. We solved it in 2 ways, both with a string and with mathematics. And then we did this, string to integer. Both really good problems. They're exercises to get into. I will be linking both of these problems in the video description as well, if you guys want to give this a try yourselves or follow along in the future. But that's gonna be it for now. For those of you that tuned in, thanks for watching. We'll see you next time.